Zoea is an AI that lets anyone produce software, simply by defining a set of test cases. The test cases describe the behavior of the program, by providing examples of inputs and outputs. Zoea then produces the corresponding code automatically. Zoea users don't need to know anything about coding. This is because Zoea already has all of the knowledge it needs about every aspect of software development. Zoea uses this knowledge to understand the test cases, determine what code is required, and produce working software. Knowledge in Zoea is organized using the Blackboard Model, a metaphorical scenario in which a group of human experts take turns to try to solve a problem. Each expert has their own speciality, however they can only communicate by writing on a blackboard that all of the experts can see. As the contents of the blackboard evolve, different experts look out for opportunities to apply their own specialist knowledge. This continues until the problem is solved. In AI, the human experts are replaced by software, and the blackboard can be any sort of database. Zoea includes a large number of experts that each cover different aspects of coding. Zoea also includes some general problem-solving strategies. These include the ability to break problems down into smaller problems, and the ability to transform problems into different problems. Most of the problems that Zoea works on internally either relate to test cases or code. Many of the experts that make up Zoea have the ability to create new test cases, which we call synthetic test cases. The test cases that are provided by the user describe the problem as the user sees it. All of the experts that make up Zoea are able to see the test cases, but each expert is looking for different things. If an expert identifies a pattern that they can recognize in a test case, then this represents a hypothesis that that interpretation is correct. For example, where an expert detects a possible transformation in some or all of the test case data, then they create a new synthetic test case that captures the transformation. This allows the experts that make up Zoea to explore many different interpretations of the test cases, concurrently. Synthetic test cases are treated in exactly the same way as regular test cases. This allows Zoea to build up a hierarchy of possible interpretations of the problem. Every synthetic test case is visible to all of the experts, although typically only a subset of the experts will take an interest in each one. The Zoea Blackboard contains a lot of other information in addition to test cases. This information is used to keep track of elements found in test cases, as well as partial and complete solutions. For example, a case solution represents a code fragment that can produce the correct output when applied to one or more individual test cases. There can often be many different case solutions for a given set of test cases, and each case solution can apply to a different subset of cases. Zoea uses an approach called set-cover abduction to identify the smallest combination of case solutions that apply to all of the cases. This technique is quite versatile and is also used for several other purposes in Zoea, such as identifying the logical expressions in conditionals. The experts in Zoea are autonomous, so it is possible either to deploy them all on the same computer, or distribute them across a number of different machines. All communication takes place through the Blackboard, so if Zoea is running on a cluster, the data in the Blackboard is distributed, to ensure that all experts have a consistent and timely view of information. Zoea also includes a central controller that looks after interaction with users, and housekeeping. Among other things, the controller initializes the Blackboard at the start of compilation, and manages the resulting solution code. In simple terms, Zoea experts operate mostly on test cases and code. All experts produce some form of code, which may be a fragment or a complete program. Some experts also produce synthetic test cases, which represent their hypotheses regarding candidate solution elements. Other experts transform existing code into different code. As Zoea transforms test cases into code, it goes through different stages, representing partial solutions of increasing size and applicability. Different experts are involved in each of these stages. The creation of synthetic test cases allow this process to contain any number of recursive feedback cycles. This enables Zoea to reason using abstractions, and helps to provide much of its power and flexibility. Visit zoea.co.uk for more information on Zoea, or follow us on Twitter.